In this problem, we need to simplify this given expression. So here we'll be using the De Moivre's theorem, which states that whenever we have cosine of theta plus iota times sine theta whole raised to the power of some number n, then this becomes equals to cosine of n theta plus iota times sine of n theta. Now our numerator part, that's fine, so we'll have to work with the denominator. So let's start. So we'll begin with sine theta minus iota times cosine theta. So what we'll do, we need actually the real part to be cosine and the imaginary part to be sine. So that means we will take negative iota as the common factor. So this gives us cosine of theta minus 1 over iota times sine theta. Fine. So now we'll need to simplify negative 1 over iota. We know that whenever we have I raised to the power of 4, this value is equals to 1. The meaning negative 1 over iota, this can be also expressed as negative. So in place of 1, we'll have I raised to the power of 4 all divided by iota, which is equals to negative. So I raised to the power of 4 divided by iota, that's iota cube. Now iota cube, that value is negative iota. That means we have our final value as iota, or we can say that negative 1 over iota is also equivalent to iota. Now our expression becomes negative iota multiplied to cosine theta plus iota times sine theta. So we have our real part in terms of cosine and the imaginary parts in terms of sine. So this is the value of sine theta minus iota times cosine theta, but we'll also have to raise it to the power of 5. So we have sine theta minus iota times cosine theta whole raised to the power of 5. That means we have negative iota whole raised to the power of 5 multiplied to cosine theta plus iota times sine theta whole raised to the power of 5. Now what's the value of negative iota raised to the power of 5? So let's find this value as well. We have negative, let's find it out here, negative iota whole raised to the power of 5, which is simply equals to negative 1 raised to the power of 5 times iota raised to the power of 5. So negative 1 raised to the power of 5, that's negative 1, and iota raised to the power of 5, that's simply equals to iota raised to the power of 4 multiplied to iota. Now we know that iota raised to the power of 4, this value is equals to 1. So that means negative iota raised to the power of 5 will be simply equals to negative iota. Right. So we can use this value and replace it here in place of negative iota raised to the power of 4. So this is going to give us negative iota times cosine of theta plus iota times sine theta whole raised to the power of 5. So let's substitute this value into our given expression. So we will get cosine of theta plus iota times sine theta whole raised to the power of 4 in the numerator, and in the denominator we have negative iota multiplied to cosine of theta plus iota times sine theta whole raised to the power of 5. So this particular expression will go to the numerator and combine with the numerator to give us, we have negative 1 over iota multiplied to cosine theta plus iota times sine theta whole raised to the power of 4 minus 5. Now negative 1 over iota, we have already obtained. The simplified value is iota. So that means this will become iota multiplied to cosine theta plus iota times sine theta whole raised to the power of negative 1. Now what we can do, we can use the De Moivre's theorem. So we'll have iota multiplied to cosine of negative theta plus iota times sine of negative theta. So we multiply theta with negative 1. Now cosine being an even function, so whenever we have cosine of negative theta, that's simply positive cosine theta, and sine is an odd function, so that means sine of negative theta will be equals to negative sine theta. Right. This means we now have iota times cosine of theta minus iota times sine theta. Now we will multiply iota to each of the terms. So we have iota times cosine theta minus iota squared times sine theta. Now we know that the value of iota squared, that value is negative 1. So that means we now have iota cosine theta minus of minus 1 times sine theta, or simply we have sine theta plus iota times cosine theta. So this is the simplified form of this particular expression. We have obtained that this value is equals to sine theta plus iota times cosine theta.